Okay, so this is Screencast 4, and what this wants us to do is, using the videos posted in the folder of this chapter, find the coefficient of the friction between the car and the ice, and the coefficient between the guy's shoes and the ice. So I split them up, and then you said to make sure we have free drawing diagram. I just like drawing the object in behind lightly so that I know. But basically we're going to draw all the forces that act upon it, which is the force on the car on the ground, force on ground on the car, and then the friction force. We have our x and y coordinate, which we always should have in the draw free diagrams. Now, what I did first was write the unknowns and unknowns. So we know that the total force of y equals m mass and the acceleration I. Same thing for x. That's our force equals m times a. We know that, so I wrote everything that I know. We know, according to the video for the car, that the displacement of the car stops at 8 meters. We know that the frame scale is 30 frames per second. We know that its final velocity is 0. We know the weight of the car because we researched it, so we actually do know the weight of the car. And then we know g, which is 9.81 meters per second squared. We don't know the v initial x, we don't know the v initial y, and we don't know acceleration in each direction either. But we will figure that out. Then the next thing I did was kind of split up the things and what we have to do and what equations we have to use according to the forces. So I split the force in the y direction, split the force in the x direction. Basically, we know that the forces in the y direction are going to equal each other and they're going to cancel each other out because there is no acceleration going in the x direction, so it's going to equal to 0. Basically, the force of n and the force of g equal each other. On the x direction, though, it's a little bit different. We have now, according to our coordinate system, friction force is going this way, and we're calling this way x positive. So we plug in everything we know. The only force we have in the x direction is the negative force of friction equals max. Now we do have acceleration on this side, we just don't know what it is. So we substituted this, which is u coefficient of k Newton, which is equal to friction. We just did it again, Newton to mg, because it's equal to that, so then that way we could cross out the m's, so we get a simple equation, which is this. So the first thing I did now was calculate the time. So I calculated that the time the car ended was 140 frames, the car started was 56 frames, that's 84 frames of distance. Calculated that, I got 2.8 seconds. Now, in order for me to find acceleration, I'm eventually going to need to use this equation. So I have the displacement, I have the time, I don't have the initial x, which I'm going to have to find in order for me to find velocity. So I just substitute it so that I'm ready to just plug and chug whenever I get my v initial x. So I went to go find my v initial x, which I just figured this formula was easy to use. Displacement equals 1/2 times time times v initial x. So I did that, I plugged in all my components, did that. I got my v initial x equals 5.71 meters per second. Now that I know that, I could go ahead and get the equation here that I simplified for myself. And I'm ready to use this and plug in everything that I know. So I plugged in everything that I know, my meters, my 5.71 meters per second in the v initial x, and then 2.8 seconds, 1/2, 2.8 seconds. I just simplified it again for myself to make it easy to plug in an equation, make sure I do it right. And I got acceleration x equals negative 2.04 meters per second squared, which is fine. Now we know from here, by simplifying our forces, and we know we came up with this, our coefficient of k equals ax over g. So we have 2, which is 9.81, and we have AX now, which is this. So we did that. So the coefficient of the car on the ice, we got the coefficient of friction is 0.208. Now the same thing with the person. We did the free drawing by-drawing, but also setting up our X and Y coordinate. And they're very, very similar in how it goes. We wrote our knowns and our unknowns, which we did the same thing into our car. We went to go simplify, which this was the exact same thing as the car as well, just because we have no acceleration in the y direction, so it equals 0. We need the friction, the coefficient of friction of the shoes and ice, so we need the x over here. We simplified it again. Obviously, we made sure that this was negative, since on our x coordinate, the force of friction is going that way to our coordinate. Then, first I followed the same exact steps. At the end was 117 frames. The start point, I calculated about 26 frames. 91 frames is the total time in between. I times that to get my seconds, which I got 3.03 seconds. Then I had to use the same equation to find my acceleration. But first, I have to find my v initial x. So I used the same thing I did with the car. Plugged everything I knew. 7.5 meters is the distance of how far he went. We know our seconds, so we just solved for VIX, which I got 4.95. Then I brought it over here to plug it in into my equation, which I did over here. I again simplified it to make it easier for myself to plug in a calculator. I got acceleration x equals negative 1.63 meters per second, although I think it should be positive here. This should be positive, but that's okay because coefficient of k equals negative ax over g. So here we could plug it in negative. Yes, it works. And then we get 0.66, or if you wanted a 0.17 force friction from the shoes on the ice.